All right, great. Thanks for the opportunity to discuss this. I have a couple comments. They're going to kind of be brief. Brief empirical comments, some high-level comments. Hopefully, they're useful for the authors, either for this paper or for a subsequent paper. You can summarize what the paper does in one slide. It's a pretty straightforward setup. So what it is going to do, it's going to try and forecast stock level returns. So a stock is I here. Right? We're going to look at monthly data, so one period ahead. And what is the predictive information that we have to bring to bear? The predictive information are holdings for a collection of types of investors. All right? So the way that we're going to consider using the holdings for these investors jointly is with some potentially flexible functional predictive relationship. Right? So I have a bunch of input data, combine it all together, think about using that to forecast returns. That's what the paper does. Right. So a couple comments on the input data, right, is that these are data that sort of start with individual institutions, either quarterly holdings or for some of the other stuff like short sales. You have it more frequently. Takes that information at the individual investor level, aggregates it up into these big bins, right? And so now you have for each stock a time series of the percent of the float or the shares outstanding for a particular firm, a time series of how much of that is held by each group, right? So we're going to put those collections of time series together, feed them through some models. Some of them are going to be fairly vanilla. Some of them are going to be fairly vanilla. They might be linear. They might use some shrinkage. They might use some dimension reduction like principal components or partial least squares. And then some of them are going to be nonlinear. So the real restriction that's implied by the nonlinear models is that you're not really allowed to consider any interactions between how holdings of different types of investors might play with each other to produce some revelation of what expected returns could be going forward. So this is where the nonlinear models start to be fairly interesting. So we're going to use two types of tree models, boosted trees and random forest. And then we're going to use some very vanilla feed-forward neural networks. Both of these models are really there. They're there partially because they allow nonlinearities, but I think we're less interested in nonlinearities about the holdings of a particular type, like are the predictive effects different when I have low holdings versus high holdings for one type, and more about the interactions among these types. All right. Now, there's a little bit of a dynamic consideration taken into account here. I'm looking at returns at time t plus 1 on holdings at time t. So in some sense, this is the most basic dynamic predictive model. It's really just one lag. They try and do a little bit more with that, which is they split out these lagged holdings into two pieces. What was the level at the end of t minus 1, and what was the change over time t? Okay. All right. So once we build these predictions, we're going to train a lot of different models, 12 different models to forecast returns. It's going to be done on a rolling 5-year basis. Right? We're going to get expected returns out for every stock because these are trained as panel models. We're going to get expected returns out for every stock from each model. And so for each model, I can do a portfolio sort based on the forecasted returns from that model. All right, so we're going to look at long-short portfolios sorted on the expected returns from each model. And then there's some extensions and robustness. We're not going to spend a lot of time talking about that. All right, so that's what the paper does. Straightforward setup. Okay, so what is the punchline? Yes, holdings information can predict returns. And when you look at some flexible model specifications that allow for interaction effects, you see like a 50, 60, maybe 70% increase in the amount of predictability that you can detect. All right? So holdings information is quite a potent predictor of returns. All right. That's the paper. I have a couple of comments on the empirics, and then I want to move into some higher level points. All right, so first, these are univariate portfolio sorts. So suppose at each date you took the holdings fraction of each type of investor, right? And you just did a sort on that standalone, okay? So that's sort of what's represented in this top and bottom panel here. Here what they've done is they split it out into sorts on two different variations in the holdings for each of those investors. Am I looking at just the change this period or the level going into the period? So the first thing here is that, a couple things stand out. Short sellers matter a lot in levels. Anybody else that matters a lot in changes. No discussion of this in the paper. This seems like a really important point. Right? If this is about dynamics, why would it be that the innovations, right, sort of the new positioning that happens today, matters a lot for some investor types but not others? If this is a genuine fact, we should try and understand because the differences are very large. All right. Another thing that stands out is that there are a couple of investor types in here that seem to be quite important. Right? By the way, these magnitudes are large. These are monthly average returns. Okay? So retail investors seem to be able to predict 0.5% a month. That's big in like an anomaly literature sense. How is that happening? Other institutions are important, right? Well, what is another institution? So there's a little bit of discussion in this. There's actually probably more discussion on this in Jeff Pontiff's paper. But the point is, it's a catch-all. We should probably try and understand what's going on there if it's such a powerful predictor. And then there are other things that we know a little bit about. So for example, mutual funds kind of predict negatively. We've seen that before in the literature. Hedge funds, the results are a bit strange. And so in any case, I feel like this is an incomplete analysis. And before we even start doing machine learning, let's do some old-fashioned econometrics and understand what's happening inside the data. Another comment. When we report results of machine learning models, whether they're linear models or nonlinear models, everything is only reported in this composite form. I get no visibility into what's happening in any of these models. This is literally an average of essentially sorts on averages of expected returns from linear models. That's LCP. This is sorts on averages from nonlinear models. That's NLCP. Right? Apparently, linear models don't do a lot more than short sellers. Nonlinear models seem to do a whole lot more. Right? There's no performance breakout by individual model type. Above and beyond that, I don't even have of visibility into the model estimates. I would love to see what one of these linear models was saying. I would love to see just what the coefficients from like an OLS or a ridge model were saying. But we don't get to see that either. So again, before we move into machine learning, this feels incomplete. Let's understand a little bit better with some traditional stats. All right. More puzzles. Okay, so when we look at variable importance, this is a way of trying to analyze in the context of a nonlinear machine learning model which variables are important. You can't just do kind of these linear things that look like derivatives and calculate t-stats. So you have to do kind of more creative things. There are lots of ways of doing variable importance. These authors choose to report one variable importance calculation. It's for one of their 12 models in one of their rolling windows. In this one rolling window, it seems totally inconsistent with the earlier results that we were just looking at from the simple descriptive stats. So for example, we see, oops, knew that was going to happen. We see short sellers way down here, not so important. All of the other sort of investor types that seem to be important in a univariate sense are not very important here. The ones that weren't important seem to jump out to the top of this plot here. So this is an inconsistency. I'd like to understand what's going on. The motivation for only doing one variable importance type for one model, for one rolling sample, was that it's hard to compute. Well, that one's hard to compute, but there are lots of other variable importance types you could consider. All right, feels incomplete. I would like to understand this better. All right, this one is a little bit puzzling to me. So what this is showing you are some of the dynamic patterns in the predictability that you get from holdings. It's saying that if I forecast returns one period ahead, I can produce a monthly alpha over Fama French and momentum of almost 2%. If I forecast 24 months ahead, I can produce a monthly alpha of 0.72, right? These effects are too big for that far out. There's something strange going on with these portfolio sorts, and I think we should try and investigate a little bit further. All right. Okay, so those, I guess one more brief comment. Okay. Benchmarking is not very helpful in this paper. All right, so what do we mean by benchmarking? We produce some predictive result, we do some sorts, it looks like there are some alphas, right? Thank you. Are we learning something that is sort of incremental relative to the previous literature? Well, I think the notion of the previous literature is just far too simplistic here. Okay, so how do I kind of think about the current state of empirical asset pricing? One way to think about it is that we have hundreds of results on stuff that predicts returns, right? This is a thing that predicts returns, and it actually looks like it predicts returns quite potently, right? So it's interesting. But I would like to know, are holdings different than that other stuff? We don't really get to see that. We get to see some Fama-French controls. We get to see some Fama-Macbeth regressions versus like 5 of these other anomalies. We should see more here. Now, this is not just about saying, like, I don't like the way you did your tests. I think the economics here are kind of important, right? Because what we're saying is that presumably investors make investment decisions based on predictor variables, right? Either implicitly or explicitly. So that means that they're probably baking a lot of this stuff into their holdings decisions, right? So I really want to know if there's incremental predictive power of holdings for returns above and beyond that other stuff. All right. The other issue is that these are machine learning-based methods, right? We're comparing to kind of the same old finance models. But there's been almost a decade of finance research of building empirical models, building empirical asset pricing models, things that look like SDFs, things that look like factor models, right? Things from which we can calculate alphas that are not considered here, all right? So we should be upping the bar to reflect a decade of research on this topic. And then this is, I think, an important detail, which is that the data dates in this data set are not apples to apples with the literature, all right? So I think I'm going to say a little bit more about this in a minute. But we're looking at the time that the holdings were actually held. We're not looking at the times that they were reported. They were reported much later, like a month or two later. Okay? So Fama-French doesn't do that. Fama-French is serious about the timing of the reporting. And actually, most of the anomaly literature is serious about paying attention to report dates. Right? There are different economic questions, and I understand the motivation for looking at holdings at the time that they were held. But this is an important consideration to keep in mind. All right, now given that I'm short on time, these are the more important points. So I should probably make sure I get through these. Okay, so what is the research question? The research question is not actually articulated in the paper, but evidently from what they do, this is the research question. Pardon me. Can I get to the right slide? Can holdings data forecast stock returns? That's the research question. And if I'm a practitioner, I say, hey, this is an interesting question. And then I look at what the paper actually does, and I say, wait, this paper doesn't even use real-time data. So it's not interesting from a practitioner perspective. You got to use the holdings at the time they were reported if you're looking at this from a practitioner perspective. All right, but let's leave the practitioner view aside. Most people in this room don't really care about that anyway, probably. Let's think about it from the economist's point of view. All right, here a lot more can be done. Okay, so I just have a couple of questions that I think could be useful, and they're actually totally approachable in the data that the researchers have. Okay, so first of all, why do holdings predict returns? Seems like a pretty obvious question given the topic. I'm going to go through some examples of possibilities just because I think their data can actually speak to this. Their data may be supplemented with a little bit of other easily accessible data. Is it informational frictions, right? Maybe news travels slowly. Maybe attention is limited. Maybe learning takes time. There's a big burgeoning literature using things like diffusion of narratives to understand behavior of economic systems. This is a great place to deploy some of that. Take things like news data and interact it with your holdings data. You could probably learn some interesting things about why this predictability emerges. Or maybe it's about institutional frictions instead. Right? For example, maybe short sellers are smart, but shorting frictions make me spread out my trades over many months. Right? Well, we can look at things like very simple, dynamical econometric models. They don't need to be machine learning models to start to learn about this. Or maybe it is actually equilibrium risk pricing at play. We don't need frictions to explain this. That could be the case if, say, for example, different constituencies rebalance upon shocks to priced risky state variables. They all do this. They all do it in different ways because they care about different things. But by studying these, we can basically back out what the price state variable is and therefore what the risk premium is. Okay? These are things that are doable with this data. All right. Here's another one. Just big question, seems really relevant from this paper. First thing I wanted to know when I started reading it. What are these people responding to make these predictions? What is it that the smart money is responding to make their positive return predictions, right? What is the dumb money, the mutual fund investors are doing that actually predicts in the wrong direction? Okay, you can make a lot of progress here. It's a little bit like just, let's say, change the problem a bit. Put the holdings on the left-hand side and put interesting stuff, information on the right-hand side. And let's try and understand what drives those holdings. Once we have a sense of what drives those holdings, then we can start to say, all right, what of those drivers actually explains the predictive patterns? Right? A little bit like a two-stage analysis to understand behaviors of investors and their impact on return predictability. All right, so this is a kind of a shout to my student on the market this year who's doing something roughly along these lines. So what she does is she looks at mutual fund holdings, and she sees how they co-move with media narratives, kind of cleverly extracted with some new methods that are out there. All right. Once you have this, you can she actually regresses things like mutual fund holdings onto measures of the extent to which narratives are present, and she can explain some degree of the variation in holdings. But what's even cooler is if you take the explained variation, drop the unexplained part, the explained variation is the thing that actually explains that negative alpha for mutual funds. The residual is, right?
Negative 1 minute.
He was +3. All right. So we have new data, we have new methods to understand this. I think I can stop there. Last comment, this is my last slide. Dynamics and heterogeneity, okay? We have an evolution of holdings of many different types of investors out there. We don't have to look at one-period models. We can look at the dynamic interplay between those. We can learn a lot about how information propagates through investor decisions through that. It's possible that this holdings data is over-aggregated in the way that it's being used here. I'd love to look at heterogeneity in these investor types and kind of better refine our understanding of what gives rise to these predictive patterns. Thanks for my extra minute.